For generations, Saturn's rings have symbolized the elegance and mystery of our solar system. They are the most recognizable planetary feature in astronomy, an enormous halo of ice and dust stretching across hundreds of thousands of kilometers. But in the year 2025, something strange will happen. Something dramatic enough that the rings will seem to vanish from Earth's view. Telescopes will see only a thin line. To the naked eye, they may disappear entirely. And as unsettling as this temporary disappearance is, scientists have announced something far more profound. Saturn's rings are genuinely dying. They are slowly being destroyed, eroded, and pulled into the planet. The magnificent ring system that defines Saturn may have only a few 100 million years left before it fades away forever. To understand what exactly is happening, we must look at two separate but related events: the temporary disappearance of the rings in 2025 and the long-term destruction of the rings themselves. First, let us explore the event in 2025. This disappearance is not caused by a disaster. It is not the result of a collision, a cosmic storm, or an explosive event. Instead, it is a predictable geometrical phenomenon known as a ring-plane crossing. Saturn's rings are incredibly wide, but they are also extremely thin. So thin that their average thickness is only about 10 to 100 meters. When the Earth's orbit lines up perfectly with the plane of the rings, we see them not from above, where they appear broad and luminous, but from the side. From this angle, the rings shrink into a razor-thin line, reflecting almost no sunlight toward Earth. Even professional telescopes have difficulty detecting them during these alignments. For casual observers, the rings seem to vanish. This happens because Saturn's axis is tilted by roughly 26 degrees. As Saturn orbits the Sun over the course of nearly 30 years, the rings slowly change their angle relative to Earth. Sometimes they are wide open and clearly visible. Sometimes they tilt until we see them edge on. The upcoming alignment in 2025 is one such moment. It has happened before, most recently in 1995 and 2009. It will happen again in 2038 and beyond. During each event, the rings do not actually disappear. They're still there, orbiting Saturn as always. It is our angle of view that changes. The event is temporary, lasting only weeks or months, depending on the geometry of the orbits. But the real story, the one that has captured global scientific attention, begins with a very different kind of disappearance. Unlike the fleeting alignment events, Saturn's rings are also fading in a literal physical sense. They are slowly being shredded and drained into the planet. This phenomenon is called ring rain, a poetic name for a destructive and ongoing process. The idea of ring rain emerged from multiple lines of investigation: infrared imaging of Saturn's upper atmosphere, magnetic field measurements, and most importantly, data collected by NASA's Cassini spacecraft during its final mission phase in 2017. The Cassini spacecraft spent more than a decade orbiting Saturn, observing the rings, moons, and atmosphere with unprecedented detail. Near the end of its mission, Cassini performed a daring series of dives between the planet and the innermost edge of the rings. During these close passes, instruments detected an intense flow of water molecules, dust particles, and charged ice fragments falling from the rings into Saturn's upper atmosphere. This was the confirmation scientists had long suspected but could not previously measure. Saturn's rings are losing mass. They are literally evaporating, eroding, and raining down. According to Cassini measurements, the rings are losing enough material every second to fill an Olympic swimming pool roughly every 30 minutes. That may sound slow, but on geological timescales, it is astonishingly fast. Extrapolated over millions of years, the rings could be entirely gone in as little as 100 million years. Other estimates suggest 200 to 300 million years. Either way, this is not long compared to the age of Saturn itself, which is over 4 billion years old. If those numbers are correct, then Saturn's rings are a very recent addition to the solar system, likely no more than 100 million years old. Some argue they may be even younger, perhaps formed from the destruction of an icy moon or the breakup of comet-like bodies. Why do the rings fall? The answer lies in electricity, magnetism, sunlight, and the delicate structures of the particles that compose the rings. Most of the ring material is made of nearly pure water ice, mixed with dust. These icy grains are constantly bombarded by ultraviolet radiation from the sun and by high-energy particles from Saturn's magnetosphere. The bombardment charges the ice particles. Some become positively charged, others negatively charged. Once charged, these particles interact with Saturn's magnetic field. Like iron filings following magnetic field lines, the particles are guided downward. They spiral along magnetic field lines towards the upper atmosphere, where they eventually disintegrate. This steady, invisible waterfall of icy debris is what scientists call ring rain. It modifies Saturn's atmosphere, creating bands of enhanced ionization and chemical reactions. Cassini's instruments were able to measure these effects directly, detecting unexpected amounts of molecular oxygen, hydrogen, and complex compounds that form when ring material vaporizes in the atmosphere. This discovery changed the scientific understanding of Saturn permanently. Before Cassini's measurements, astronomers assumed the rings might last billions of years. After Cassini, the rings suddenly seemed temporary, like a rainbow frozen in time, destined to vanish far sooner than previously believed. The implications of this are enormous. If Saturn's rings are young and temporary, then we are living in a uniquely privileged moment, one that future observers millions of years from now will not experience. Humans evolved at precisely the right time to see Saturn at its most magnificent. The rings we marvel at today are nothing more than a fleeting decoration in planetary history. Now, let us return to the temporary disappearance in 2025. During a ring plane crossing, even large telescopes can struggle to capture the thin line of the rings. For a general audience, it is easy to misunderstand this event as a sign of destruction. The timing is coincidental, but it provides a perfect opportunity to connect public interest with the long-term fate of the rings. As the rings vanish from view, astronomers will use the moment to communicate the deeper truth. Saturn's rings are not eternal, and the processes that sculpt them are ongoing. The rings themselves are incredibly dynamic structures. They're shaped by collisions between particles, gravitational interactions with Saturn's many moons, and subtle forces like radiation pressure. The gaps in the rings, such as the Cassini division, are not empty, but filled with finely balanced orbital resonances. These structures behave like cosmic machinery, with each moon tugging and shaping the ring particles in ways that astronomers can predict and model. Despite their massive size, the rings are fragile. A slight shift in gravitational balance could disrupt them. A massive collision or impact event could add new material, reshape the structure, or accelerate the destruction. And over long enough timescales, the competing forces, gravity, magnetism, sunlight, and microscopic collisions all work together to erode the system. One question often raised is whether Saturn's rings have disappeared before. The truth is that we don't know. If the rings are young, they may be the most recent version of a cycle of destruction and rebirth. A former moon could have drifted too close, crossing the Roche limit where tidal forces tear objects apart. Such an event could have created the present rings. In the future, another moon might suffer the same fate, forming a new ring system long after the current one fades away. Another possibility is that the rings will simply thin out instead of vanishing entirely. Some models predict that Saturn will eventually have faint rings similar to Jupiter, Uranus, and Neptune. These planets have ring systems too, but they are extremely thin and almost invisible. Saturn may eventually join them, losing the bright, majestic bands we are familiar with and becoming just another gas giant with faint debris circling around it. The year 2025 will serve as a kind of preview, a moment when the rings appear to fade, letting astronomers demonstrate just how delicate and transient they truly are. Anyone observing Saturn through a telescope during the alignment will see a side of the planet that is rarely visible. For a brief period, the world's most photogenic planet will appear stripped of its most defining feature. It's a reminder that even the largest structures in our solar system are subject to change. We often imagine planets and their features as permanent, unchanging.